Okay, so when I'm factoring this first question, I want to use man method. It's a trinomial and I don't have an a value there. So my m is just this number, negative 27. My a is just negative 6. And I want to find two numbers that multiply to give me negative 27 and add to give me negative 6. So typically you think of your multiples first. You can do it a lot quicker, but I'm going to list them. So 1 times 27, 1 plus or minus 27 will not give me 6, so that doesn't work. 2 times anything does not work. 3 times 9. Now I know 3 plus or minus 9 will give me negative 6. So my two numbers are 3 and 9. And I know if I want to get negative 6, I have to 3 minus 9. Now once I get my two numbers, I can just write my solution x plus 3, x minus 9 in factored form using my two numbers. The second one, this is just an example of difference of squares. Since the sign is a negative and they're both square rootable terms, you can just make your two brackets. The square root of 25x squared is 5x. Always make the signs the opposite in difference of squares, and square root of 49 is 7. This one here, it might look like a trinomial with man method again, but again, it's actually perfect square, and the reason why is the first term is square rootable and the last term is square rootable as well. So for perfect square, you just square root the first term. The square root of 4x squared is 2x. You always take the sign from the middle, so plus, and you always square root the last number, which is 5, and then you put a square outside it. Now just to be 100% certain we're right, typically I expand perfect square to make sure I get the exact same solution. So 2x times 2x is 4x squared. That's plus 10x plus 10x plus 25, 4x squared plus 20x plus 25. So it's definitely the right solution. And this last one here again is a trinomial, but now we have an a value. So we're going to do the second man method. It's slightly different from the first one because we have to do decomposition after as well. We can't just list our solutions straight away. So my m now is the first number times the last number, which is negative 12. My a is just the middle number there, negative 1. So my two numbers are 3 and 4, and the 4 is negative. Now since I have an a value, I can't just write x plus 3, x minus 4. I have to do further steps. I have to do decomposition. So 6x squared plus 3x minus 4x minus 2. I've basically used my two numbers to break that x down into these two. Next I'm going to put a small line over there. I'm going to factor this by grouping. So my common factor is 3x, 2x plus 1, and over here it's minus 2, 2x plus 1. You'll always get the exact same term in the bracket, and then we're just factoring out 2x plus 1. So what's remaining is what's on the outside, which is 3x minus 2. Okay, so this next couple of questions are going to be 4-term questions. Now there's a couple of different ways you can do 4-term questions. The first way you should always try is make a little line over there and try to factor each side by grouping. So over here I can group out a c, and I'm left with a plus b. And over here I can group out negative d, and I'm left with a plus b. Since grouping works and my brackets match, I know my final solution is a plus b, c minus d. So always try grouping first in 4-term questions. Let's try 6 again. So my common factor here again is x squared, left with x plus 1. And over here I can group out a negative 1, and I'm left with x plus 1. So I have x plus 1, x squared minus 1, but this is not fully factored. Remember, you can factor this bracket by difference of squares. So you have x plus 1, x plus 1, x minus 1, because those two brackets are the difference of squares of that one. Let's take a look at number 7. So number 7, if I try to put my line in the middle and if I try to factor by grouping, nothing's really going to happen because I won't get a common bracket. So if factoring by grouping doesn't work, you want to try a second method where you're looking for 3 terms as the trinomial and the 4th term is separate. So over here I notice x squared plus 2x plus 1, that's a perfect square. That's my trinomial. If I factor this perfect square right here, I get x plus 1 squared, and then I just have minus y squared. Now if I look at this, I have one term being squared minus another term being squared. It's just difference of squares. So for difference of squares, I'm going to make the brackets extra big for this one. You know, you have opposite signs in the middle of the bracket. The square root of x plus 1 squared is just x plus 1. And the square root of y squared is just y. And here again I have x plus 1 minus y. Then I just have to get rid of the inside brackets. So it's x plus 1 plus y, x plus 1 minus y. Okay, and same idea in number 8. If I try to group, there's nothing that works here. Doesn't really work here either, so I know I have to do the trinomial method again, but the order is not good, so I'm going to start by rearranging it so that the a term is right next to this one as well. So I have a square plus 10a plus 25 minus b square. Now these three again give me a perfect square, which is just a plus 5 square minus b square, and then this is just difference of squares plus minus, the starting is just a plus 5, that's the square root of that. The square root of b square is b. And again over here I just have a plus 5 minus b, and that's my final solution. Okay, so in this one, the first thing I'm going to do is look for a common factor, which is 2x. So if I take out 2x, I'm left with 2x squared minus 3x plus 1. Now I have a trinomial in here, so I have to try factoring that using the second man method. My m is 2 times 1, which is 2. My a is negative 3, and my two numbers are minus 2 and minus 1, so it is possible. I'm going to factor it here on the side. So 2x squared minus 2x minus x plus 1. My common factor here is 2x, x minus 1, and over here minus 1, x minus 1. So 2x minus 1, x minus 1 is the solution for that. I'm going to come and write it in here. Don't forget to put the initial 2x which you common factored out. Then that solution 2x minus 1, x minus 1. Okay, let's go to number 10. This one I'm just looking for a common factor. I know I can divide all the numbers by 3. X cubed, x squared, x. I can take out an x. Y squared, y4, y3. Can take out a y squared. Over here I'm just left with x squared minus 3xy squared plus y, and that's my final solution because that's not a regular trinomial, cannot be factored. For number 11, I know you're tempted to maybe expand, but if you notice the brackets are exactly the same, so it's just the middle step of decomposition where I take a plus 1 out common and I'm left with the final factored solution in one step. Same thing with number 12. All the three brackets are x plus 1s, so don't expand. Just take out a common factor of x plus 1 and you're left with 7x squared minus x plus 6. Now we got a trinomial in here, so we got to try our man method. My m is 7 times 6, which is 42. My a is -1. And if you think about this, my only possibilities would be 7 and 6, but if they're both positives or both negatives, I can never get -1. So it's not really possible to factor that, which means that right there is my final solution. Okay, so if I take a look at this question, I'm trying to factor it. Now the brackets are the same, so I have to start by expanding. So that's going to be 10x minus 5x squared plus 8x squared minus 20x minus 3x plus 4. After I expand, I'm going to combine like terms. I'm going to start with my x squared terms. So -5 plus 8 is 3x squared. 10 minus 20 is -10, minus 3 is minus 13x. And then I just have a plus 4 at the end. So now I have a trinomial. I'm going to do my man method. 3 times 4 is 12, -13. My numbers are -12 and -1. So I have 3x squared minus 12x minus x plus 4. Going to group them. So 3x, x minus 4, minus 1, x minus 4. So 3x minus 1, x minus 4 is my solution. Same idea for number 14. That's not really a common factor, or there kind of is, but we can take it out later. So I'm just going to expand first. 40 cube plus 16t squared plus 8t minus 60 cube plus 12t squared minus 34t. I'm going to combine like terms next, so that's -2t cube, 16 plus 12 plus 28t squared. 8 minus 34 is minus 26t. Okay, now I have a trinomial. I want to take out my common factor first. If your first term is negative, you always want to take out a negative. So I'm going to take out -2t. That's my common factor. And I'm left with t squared minus 14t plus 13. I'm going to do my regular man method. There's no a value here. So my m is 13, my a is -14. My two numbers are -13 and -1. So I have -2t, and I can do this instantly. T minus 13, t minus 1. Since there's no a value, you can just sub them in immediately. Okay, so this next one here is a trinomial. It's just got a b and a b square, and the numbers are slightly larger, which is why I want to show this one. So my m is 8 times -21. I'm going to do that in my calculator because a bit too large. So -168, and my a is -2. So now when you're trying to figure out your two numbers, if this is too large to do without a calculator, I can show you how to do it with one. So you just want to type 168 and you want to divide it by some random numbers. Let's say I start with 6, for example. So 6 and 28, that doesn't give me a difference of 2, so I'm going to change that 6 to an 8. 8 and 21, again, doesn't give me a difference of 2, I'll make it like a 12. 12 and 14, that gives me a difference of 2, so I know my numbers now are 12 and 14. Since I need an addition of -2, the 14 is negative, and that's a way in your calculator. It's a quick way for you to get your two numbers if the multiples are too big. So now I'm going to rewrite it as 8a squared plus 12a b minus 14ab minus 21b squared. I'm going to put my line in my middle and do grouping. My common term here is 4a, 2a plus 3b, and over here it's -7b, 2a plus 3b. Brackets match, which means my solution is right. 2a plus 3b, 4a minus 7b. Same thing with this, it's a bit of a hard one because the numbers are so large, there's no perfect square at all. What I do notice is there's a common factor. So I'm going to take out my common factor of 2 to start off with. 8x squared plus 38x plus 45. Now I'm going to do man on the inside. The numbers are still extremely large. So 8 times 45 is 360 and my a is 38. So again, I'm just going to do this in my calculator. I'm just going to type 360 and I'm going to divide it by a random number like 10. 10 plus 36 does not give me 38, so I'll change that to 12. 12 plus 30 does not. Change it to 14. That doesn't work. 16 doesn't work. 18 and 20 give me my solution. So again, when the numbers are too big, just type them in your calculator and use your calculator to get the solution. So that's 8x squared plus 18x plus 20x plus 45. Do my grouping, so 2, 4x, 2x plus, oh no, that's a 2x, not a 4x. 2x, 4x plus 9 plus 5, 4x plus 9. So my final solution is 2, 4x plus 9, 2x plus 5. And then if I take a look at number 17, that's square rootable, so I can do difference of squares over here. The square root of x8 is x4. But this is not complete. What you notice is you cannot factor this one here, impossible, but you can factor this because it's a minus. So I'll write the first bracket the same. But this, the square root of x4 is x squared plus 1, x squared minus 1. Now again, if I look at this, I cannot factor these two brackets, but I can still factor that final one. That's x4 plus 1, x squared plus 1, and then this one turns into x plus 1, x minus 1. Okay, so if I take a look at this again, that whole term is square rootable, that is also square rootable. It's a minus sign in between, so I can just do difference of squares. Bit difficult with this one, but let's try it. So I have my two brackets. The square root of this whole term, the square root of 9 is 3, and the square root of y minus 1 square is just y minus 1. Then we've got a plus. The square root of 25 is 5. Then 3y minus 1 minus 5. Now all I have to do is simplify the two brackets. I'm going to start by multiplying this in. So 3y minus 3 plus 5. 3y minus 3 minus 5. And then I'll combine like terms. So that's 3y plus 2. 3y minus 8. Exact same thing with this one here. However, this is not square rootable because 3 is not square rootable, but what I notice is there is a common factor of 3 in both these terms. I'm going to start by taking out the 3, put a nice big square bracket. That's x squared minus 9, 2 minus x squared. Now you notice with these two terms, they are both square rootable, which means I can do difference of squares. So again, I'll write my 3, I'll put my big square bracket. The square root of x squared is just x. I'll put a plus. The square root of 9 is 3, and the square root of 2 minus x is, square is 2 minus x. And then it's just x minus 3, 2 minus x. After this, all you have to do is simplify the insides of the brackets. I'm gonna do it a bit to the side. I guess I can do it here. So 3x plus 6 minus 3x x minus 6 plus 3x. And I want to combine like terms, so I'll continue over here. I write the 3 the same, square bracket, x minus 3x. So I don't need that. So 3, 6 minus 2x, 4x minus 6. Now I can simplify a bit more. I can take out common factors from inside these brackets. So over here I can take out a -2 or a +2, whichever one you want. I'll actually take out a -2. So that's going to make it -6. And that's going to turn this into x minus 3. And then I'm going to take out a 2 from this bracket, so that becomes -12 x minus 3 to x minus 3. Again, the pretty complicated step here was in this one where I factored out a -2, and that's how I got x minus 3, but that's again definitely something you want to know. And then question number 20, I have this. Again, you can do difference of squares here, but the problem is the sign is a plus and there's a minus here, so I'll start by taking out a negative, p square q square minus 81. And now it's easy to do difference of squares on the inside. So negative, the square root of p square q square is pq, so pq plus 9, pq minus 9. Okay, so in this one I noticed that the brackets are similar but not the same. The terms are switched. So my first step right here is to change this sign from a +7 to a -7, and that's going to change the bracket to x minus 3. And now our brackets match, so we can just factor that out, x minus 3, 2x minus 7. And this last one here, a bit of a difficult one, but again, not too hard. You have x4, x squared, and then a constant. So I'm going to replace y with x squared. So this is going to become y squared minus 5y plus 4. Now I can do my man method on this. -4, -5, my two numbers are -4 and -1. So I have y minus 4, y minus 1. Now once I've factored this, I want to replace my y's back with x squares, because that's what was in the question. So x squared minus 4, x squared minus 1. And now I can factor this by difference of squares, so that's x plus 2, x minus 2. Same with this one, that's x plus 1, x minus 1.